Hello, we are Baja Development. Please enjoy our senior project video.
We are one of 5 teams completing a senior design project at Lake State this year.
Lake State is the home of a multi-million-dollar ABET accredited engineering facility.
The university is located on the St. Mary's River in Sault Ste. Marie, Michigan, the 3rd oldest city in America.
Join us as we walk through our process for beginning the development of LSSU's new off-road race kart.
LSSU's SAE Baja Club provides students the opportunity to get hands-on experience with designing and building a competitive off-road racing vehicle. These vehicles are taken around the country to compete at various events, which include a 4-hour endurance race and design competition. The Baja Club has had active participation in regionally renowned performance since 1989.
Our task was to begin the replacement of our old Baja race kart. This includes everything from the engine to the ends of the axles, leaving the other subsystems of the kart for the next team.
Our initial research included innovative designs such as string drive and reactive suspension.
However, after weighing up our options, we decided that a simple design would be more robust. To find the design criteria that we were looking for, we began simulation using MATLAB and other tools we created. We then used those simulations and design criteria to choose parts and components. Of course, there were parts that we couldn't buy off the shelf, so we had to design them, like the steering knuckles. Throughout this whole process, we conducted design reviews with industry experts to make sure we were on the right track throughout the project. After we finalized the design and components, we started construction of the drivetrain and testing system. Our components were built into a modified version of our old frame from previous projects.
Our testing procedure followed a 5-step process to make sure our drivetrain was functioning from the very base level, following all SAE regulations and performing at the highest level and for the longest time. It included testing the system statically, dynamically, and thermally using LSSU's state-of-the-art thermal imaging equipment. We also used vibrational analysis to verify the effects of vibrations on our system.
Our final product is an on-demand 4-wheel drive power delivery system with Rhino 2.0 chromoly CV axles in the front and rear. The drivetrain has a transmission system from a Polaris Sportsman 570 4x4 that has low, high, reverse, neutral and park gears when combined with our Gauge GX9's continuously variable transmission. We also created simulation programs in MATLAB so that the following groups can create designs that are backed up by numerical data.